Hello viewers and my dear students. Welcome to session 6 on thermal analysis. I was showing a demo on 2D heat conduction on a plate in the previous session. Okay, and we were at this stage. That means I'll give you some of the things what I've done in the last session again. See here, this was the vector plot I was telling you. See here, this edge is subjected to 100, this is subjected to 100, this is subjected to 200, this is subjected to 100, and this is purely a conduction problem where the high heat flows from higher region to lower region. In that way, so much heat is being wasted to the surroundings in this way. See here, red mark, it is almost 61,833 watt per meter square. Okay, of heat is being sent to the atmosphere or is being here, that is, you can call it as heat loss to the surrounding. Okay, now as you know here, this is this is 200, this is 100, a small amount of heat. Notice here, from higher region to lower region, that is a higher temperature to lower temperature, this is 100. No, some amount of heat is being lost to the surrounding in this way also. Okay, that is almost, that is green. No, that is 27,718.1 watt per meter square. Since this 100, this is 100, the heat cannot go in this direction or in this direction. They always occupy this region. That means that is a region of higher temperature to lower temperature. Anyway, this green also, here also you can see some 100 degree here. This is 0 degree. So much 27,718.1 watt per meter square of heat is being lost to the surrounding even here. Okay. See here what I have shown you. I'll repeat in the exam and all that. What you have to do is, first is after solving contour plot, nodal solution. Okay, first dy solution, nodal temperature. This temperature plot you see. Okay, this compulsorily you see here. This is here you see is 200 and small amount. This is less than 200 because this 100 here. Okay, the 200, some amount of heat is being dissipated. That is lost to the surroundings here. As a result, this may not be 200. Only from here to here it is maintaining 200. Here it is little less than 200 because the heat transfer takes place from higher region to lower region here, from here to here. Okay, this is almost to the 0 degree, and this is the pattern. You see here the green pattern. You see here 88 degrees. This one almost 44 degrees. In that way, this is 22 degrees. This is 0 degree. In that way, you can understand. Okay, see here, this is a very important thing. You have to write meta file of this, invert white and black and all that, capture the image. Okay, that means this black will become white. Anyway, it will be in the paint. You can take the print of it and you can give it to the examiner, or you can have it in your records pasted. Okay, these are all very important. This is the temperature plot, is the first one. Okay, then next, okay, next is nodal solution. Then thermal flux plot. This also you have it. Thermal flux plot. Thermal flux vector sum plot. Okay, this also you have it. Okay, just have to wait sometimes. It takes some time. Okay, this is thermal flux plot. This also under plot controls. Okay, and write meta file, invert white and black. In that way, capture another file and name it as thermal flux plot. And another important thing, as I said just now, vector plot is another plot predefined. Flux plot, thermal flux plot. This is vector plot. No, this is a very important thing. As I've been you, how the heat escapes from the region of higher temperature to the lower temperature, how the heat escapes to the surroundings. That will be clearly given here. This is the thing. Okay. Now, if you refine the mesh and all that, there might be change in the answer. We'll talk about the convergence and all that. For the examination purpose, you do this and make it enough. That is, you concluded this. Anyway, I'll be showing you, in case I change the mesh, you get better results. The accuracy, it will come to this. Okay. This is I have done here 10 here. I think here I've done 15. 3, 6, 9, 12, 15, 18, 20. 20 here. This is 10. 10 and 20. That is 200 elements you have here. Anyway, this is the thing what I have done right now. Okay. Now, if you see here, here it is 200. Okay, 200. In the plot also, temperature plot you have seen, except for a small region. Okay, this is 10 meters. This is 20 meters. In the 10-meter graph, if you draw right now, initially it will have little less than 10 and the little less than 200. Afterwards, it becomes stable. This you remember plot results. Okay, remember, I'll tell you again, contour plot, nodal solution, DOF solution, nodal temperature you see here. This is the thing. Here you have little less than 200 and after that it is 200. But they've asked you in one of the questions, you have to draw the variation of the temperature along this line. That means initially it will be less than 200. Afterwards it becomes 200. Okay. On 10 meters. That x-axis will be 10 meters because its length is 10 meters. Okay. This you remember clearly. Now I'll show you how to draw that. Okay. Then path operations. Define path by nodes. Okay. I'll get the elements. Okay. Now plot. In this, if it is a straight one, no, you don't have to select all the thing. You select the first one and the last node. That is enough. Okay. Use path. Then you say okay, and then you say here you give your name. Okay. Then you say okay. Then see here next map onto path. On that line, what you want they ask. The DOF solution temperature. Temperature plot I want on this line. That means from here to here I want the temperature plot. I'll fix it to temperature. Okay. DOF solution temperature. I'll just say okay. Okay. Then plot path item on graph. If you show temperature, okay, it will clearly show the temperature. You see here, this is 10 meters now. Initially it will be less than 200. Okay, for only a small region, only for 1 meter. Totally 10 meters now. Only for 1 meter, it will be less than 200. Slowly it is increasing from 100 now. It is 100. It is slowly increasing to 200. After 1 meter, it is maintaining 200 as I've just now shown you in temperature plot. Okay, this is also another graph what you have to compulsorily store. Right, meta file, invert white and black. In that way, you show another plot. This is plot number 4. What you have to show. Okay, these are all the things I've shown you, and please understand there are some things here. I'll show plot elements. I'll go back. Okay, plot elements. I've shown you all the things. What all have been asked by the in the problem 1. What all I've asked, I have shown you how to do. Okay, now you see here. Some of the times you get a doubt whether you entered the constants, that is properties and all that properly, whether you have applied the load properly and all that. For that, always you take care of the list. List, loads, solid model loads you do. Once you do solid model loads, you see here, this is line 1 is 100, 2 is 0, something like that. You don't know what exactly is that. That is why what I'll do, plot controls, numbering, I'll make line numbers on. I just say okay. Okay. Now I'll say plot lines. Now if you see here, plot lines, L1, you see here, line 1, it is 100 I have applied. That is correct. Correct, no? I think you are sure. L1 you have applied 100. L4 is also 100. That is also correct. L3 you have applied 200. This is also correct. L2 you have applied 0. That is also correct. In that way, you can verify yourself what exactly the loads applied and all that. Okay, that is one thing. Then plot elements, we'll come back to this. Okay, now let us say if you get a doubt whether what I've applied that properties, no, that is list properties, all materials. That properties is 401 watt per meter degree centigrade. That is the thermal conductivity of the material. This, if you get a doubt, you just see here, you are getting the answer. This is 401 watt per meter degree. That also you entered it correctly. In this way, whatever is the thing, okay. Areas also, you just see the area you get, okay. Then if you want list key points, coordinates only. See here 0, okay, 0, 0, 10, 0, 10, 20, 0, 20. In that way, the key points also you can get. In that way, so many things what you've done. In case you're getting a doubt, you can verify it. Okay. Now see here, this before I conclude this session, I'll just show you how to refine the mesh. See here, I've told you more the number of elements. Here, your 10, this is 20, I think. Okay. This is 20, 20 into 10, 200 elements are there. If I make it 300, the answers will be much more better. Okay, 400, it will be much more better. Afterwards, it becomes horizontal. Then you will be in a position to say, if you make this as so many elements, your answers will be proper. But right now for the examinations and all that, you don't have to work on the conversions and all that. But at least I'll tell you fast how to remesh this. Okay, see here, preprocessor, I'll remesh, okay. Under modeling, no, modeling, here you have a meshing. Mesh attributes is, mesh attributes, default attributes. Don't change that. Default, only one material is there. Okay. Okay, only one material, that is okay. Then, if you see here, under size controls, no, under size controls, lines, picket lines, here and here, I have right now made 10 elements. Now I'll make, let us say 15. I'll just say apply. Then I'll take this and this, and if I say this 30, okay, this will be 30. This is 15, 30. Okay. Then you see here, if I take, say, mesh areas free, if I click this and say, see carefully, some of the picked areas are already meshed because I've already meshed now, taking this as 10, this as 20. Now I've increased. Do you want to remesh them? Yes, you say. Okay. See here, the mesh has been remeshed. Okay. In that way, now you solve that. Solution, solve, current ls, you are getting better results now. This is called remeshing procedure. You just have to see here. That is why it's taking too much time. Now it is, see here, solution is done. Close, file, close also. Okay. Now I have got a better mesh. Then once you do this, the answers will be still more better. Okay. Plot results, contour plot, nodal solution, nodal temperature. In that way, you get the temperature plot, and that vector plot also you take them predefined. This also you take it. Okay, it has increased now. See here, difference in answer because more the number of elements, you are getting even a higher watt per meter square. That is heat loss to the surroundings. Okay, this is all you can do. In the same way, everything you can do. Okay, even draw variation of temperature along this and all that you can do. One more thing before I finish, animate, deformed results. Okay, temperature. Okay, if you say here, you see here. Now it is 0. Now how beautifully it is coming, you see. Once this is maintained 100, 100, this is 200. They beautifully you are getting how exactly. Now it is 0. Blue is 0. Now as you maintain the temperature, see different bands. Bands telling different temperatures. This is 0. Red is 200. Okay, in that way, this also you can show. Okay, okay. Thank you, friends. This is the end of session 6, and we have finished the problem. We'll do some other problems in the next session. Thank you very much for watching. Thank you.